Inside Oxbox. A deep dive into Oxford Biomedica's latest and largest facility. Spanning over an impressive 7,800 square metres, Oxbox is purposely designed to increase our manufacturing capabilities. It's here that we make viral vectors, a technology used to deliver gene therapy products into a patient's cells. Oxbox consists of 6 state-of-the-art manufacturing suites, 4 of which are dedicated to viral vector production and 2 for fill and finish. The whole manufacturing process takes several weeks to complete, so batches are made concurrently in each available manufacturing suite. Oxbox also houses supporting areas such as warehousing, cold chain facilities, and quality control laboratories. All raw materials are processed through goods in and are sorted and stored at varying temperatures. Once required for batch, materials are passed through the material transfer area. Here, they go through a series of rigorous cleaning and disinfecting processes. Throughout the entire manufacturing process, we carry out extensive environmental monitoring and testing of product samples to ensure the integrity of our manufacturing processes. Oxbox has 4 identical vector substance suites, each split into 2 areas: a cell build room and a vector production room. Once inside the cell build room, the cell bank vial is thawed and cells are grown to larger volumes. Maintaining conditions for good growth is critical. Temperature, pH, nutrient and oxygen concentration levels are continually monitored. Cells are grown in flasks and are then transferred to larger vessels containing more media or food, which in turn allows more cells to grow. These cells are then placed into a shaker incubator, and the process is repeated until the correct number of cells is reached. When ready, the final and largest flasks are used to seed the 50-litre bioreactor. Cells are grown in the 50-litre bioreactor to a concentration high enough to seed the 200-litre bioreactor. Depending on the size of the batch, the 200-litre can be used to seed a 1,000-litre bioreactor. Once the cells have grown to the required concentration, transfection takes place in either the 200-litre or 1,000-litre bioreactor. Transfection is when the cells are taught to produce the product, in this case, the viral vector. After transfection has been performed, the cells are left to produce the required viral particles before the bioreactor contents are filtered or clarified to remove cell debris, producing a liquid containing the product viral particles. Anion exchange chromatography is the technique in which the product is further concentrated and purified. The process begins with a column, a type of filter which has positively charged particles bound to the inside. As the product enters the column, the virus, which is negatively charged, binds to the positively charged particles, allowing any cell debris and waste to pass through and separate. Buffers with increasing salt concentrations are passed through the column, which then displaces the virus particles. These are then collected separately from the waste in a purer form. After chromatography, the product is further filtered and concentrated using a hollow fibre filtration process. The product is then put into storage containers. This process is known as aliquoting. The containers are placed into freezers, stored frozen, until the final fill and finish stage of the process. Fill and finish takes place in an isolator, a controlled and sterile environment where the risk of potential contamination is extremely low. Once removed from the freezer, the storage containers are thawed in water baths. The liquid is then pooled into a single container and sterile filtered to ensure a sterile final drug product. The vector product then goes through hollow fibre filtration for further concentration if required. This is very similar to the previous process. However, this time it takes place in a smaller column. Vials are filled with the product and capped inside the isolator on a fully automated filling line before being inspected, labelled and packed and placed back into the freezer ahead of distribution. Our investment in Oxbox continues. Over the next 2 years, we'll be developing the remaining 2,000 square metres in the fallow area, creating a flexible, advanced manufacturing space for viral vector-based products, including vaccines. These new cGMP suites, designed to operate bioreactors of up to 2,000 litres, will further increase our capability and capacity to manufacture life-saving cell and gene therapies.